This is universal indicator. It's actually a mixture of several indicators which not only tell you whether a substance is alkaline or acid, but actually gives you a reading on the side. Now, you people haven't done pHs yet, but pHs are on a scale from 1 to 14. From 1 to 6 is acidic, and it will have specific colors, sort of from the yellow to red is the acids. The middle color, which is a pH of 7, because halfway between 1 and 14 is 7, is neutral, which is green. And then 8 to 14 will give you the greens right through to the blues and the purples, and those are alkaline. So the usefulness of universal indicator is that it not only tells you what is acidic or alkaline, but actually gives you the reading of the pH reading of it. So we're going to look at those same substances now and get an idea of what their pH was. I'm going to take a little bit and put it into each of these. There's our vinegar, and I'll go back to these in a second, and I can't read these in behind. You see there, it's going blue. That's the washing soda, isn't it?
Washing soda.
Right. I'll show you each of these individually, and we're going to read the pH values. Usually only need about 2 or 3 drops in each of them. That should actually turn darker than it is. Right, you can see they've changed color, but if you compare it with the chart on they either give you a chart on the bottle or a piece of paper, you can get the actual pH readings. I'm going to just stir it with this. So having a look at the vinegar, it's a very light orange, and you compare it to the colors here, and this is a pH of round about 5, okay? 4 or 5. Let's see if there's any lighter color. No. Okay, that's pretty much a pH of 5. So vinegar is a what we call a weak acid, because close to 7 is neutral, and a very strong acid is 1, so 5 is a weak acid. All right, moving on to the washing soda, and this is actually more correct than our, except, I'm just seeing there's a little bit of color in here still. This is a strange sort of color, like almost on the line. Okay, close to 6, around about 7 almost. It's like between the yellows and the greens. It should be slightly more alkaline than ours is. There's something faulty with ours. But this is usually a slightly weak alkaline. This is almost on the neutral line, almost green. Right, moving on to the salt water. Let's give this a stir. This is definitely green. All right, green right over there. pH is 7, almost. Our water is actually almost turning a little bit blue. It's like a darker green. So which suggests there are some chemicals in our water, but it's close to neutral. Moving on to the lemon juice. You compare the lemon juice to the vinegar, you can see that the lemon juice is a slightly darker color than the vinegar, indicating that it's a stronger acid than the vinegar. And let's have a look at the value. Right, quite strong. Pretty much 4, around about 4. Okay, do you think it's darker than that? No, I'd say pH of 4. It's probably the closest color reading we can take for that. Okay. Then we come to the bleach. I think there's a problem with our bleach too, because usually it's definitely very alkaline. This is also, it's around about 7. Yeah, it's sort of a light, that sort of olivey green almost, which is about 7, but it should actually be darker than that. But it is on the alkaline side. Then we come to toothpaste, of which the color of the toothpaste is really oh my goodness, it shouldn't be there. It should be green, all right? And the toothpaste color, but I did see a little hint of green right at the beginning. Not so clear because the toothpaste color. But toothpaste should neither be acidic nor alkaline because it mustn't corrode your teeth. The same with shampoo. We've tested shampoo before. It should be neutral. And lastly, the water. Just plain water. Okay, that is green. Okay, that is a pH of 7. This one's almost 8. Okay, it's in between 7 and 8. We've got slightly alkaline water here, but normally water is neutral. Okay.